Well, this one's going to be fun. We're going to take a look at the network connections, logical diagrams, and applications that are running through our service provider environment. Let's start off with the service provider physical connection. What we can see here is one example of a topology that a service provider might run, and they come in different shapes and sizes. Over here is what I would call the service provider central office, or I'll call it a data center in this case. And can I tangent in just a moment? Service providers doesn't necessarily have to mean that you're feeding neighborhoods and businesses and T1 lines and all that kind of stuff. You could have maybe your own little data center that has multiple uplinks to other carriers. Maybe this is our we'll call it CBT SP, the CBT Nuggets service provider, and we have uplinks here to Level 3, to Global Crossings, and to AT&T. Right, 3 different carriers that we have, and maybe all we do is we have this data center where we allow people to come and bring their servers and locate them in our data center. They pay us monthly for that, and in return we give them, generated power to where if the electricity gets cut, we can generate our own power. We have 24/7 security. We have ultra redundant connectivity, fiber optic cable running straight from each one of these carriers. So we could make a service provider business just by running our own little data center. We don't necessarily have to reach out to the neighborhoods, but let's say we do. What you can see is our cables coming out here. Anytime you see this symbol, if you haven't seen it before, that is a fiber optic cable. So this is our DWDM cables we were talking about in one of the previous nuggets. That is, multiple light wave signals. It's virtually limitless bandwidth, if you will, that we could send using different frequencies to these little pops. So this is maybe a central office where we terminate our fiber and then we reach out from there. Now notice we can run, depending on the cost or what's available, we could run fiber direct to our customers. So these are all of our customers over here. Maybe this is a business, 50 people in a building, 500 people in a building, we don't care. It's fiber. So we could essentially go up to, whatever bandwidth we want. Let's say we provide 100 megabit per second symmetrical. I'm going to throw symmetrical out there, which means the upload and download speed are the same. Now, a lot of you'll see as we go through, a lot of different cables will have different frequencies and different limitations that they're able to handle. Fiber, being the way it is, is typically a symmetrical connection, so our upload and download speeds are the same. Now, remember, from a customer's perspective, they're usually, not always, usually more concerned about downloading, meaning they have their employees that are surfing the internet, that are receiving information, receiving emails, with very little concern about the upload speed. Again, I'm saying in some cases, unless they're hosting things out of there, they run their own, we'll say, email server or web server or something like that, then maybe the upload speed is a concern. But fiber optic is symmetric, so we don't really mind. It's upload and download speed. Maybe this is a 1 gigabit per second customer that we're feeding out of this office right here. And then we have, for instance, a customer that's using copper cable. Now, copper cable is going to usually be using, especially if we're talking DSL, the phone lines that are sitting in the ground and have been run there for years and years and years. DSL essentially will have most of the time a asymmetrical, meaning you'll have different upload, and this will be the same for copper, different upload and download speeds. Why? Because copper, first off, is very limited in how much bandwidth it's able to carry, especially when we're talking about telephone wire that is usually used as that copper. So number one, we have the limitation of the cable itself. So what is done is you look at the frequency and you say, okay, well, you only have so much bandwidth or frequencies that can be sent over that wire. So we're going to lean it a lot heavier to the download direction and use most of the frequency that's available on that cable for downloading and a very small frequency range for uploading. So you might see, for instance, a download speed of 40 megabits per second, even though I pointed upload, and an upload speed of 1 or 2. Because again, a home, what are they doing? They're usually not hosting stuff out of there. They're playing their online games. They're streaming movies on their television. They are downloading files from the internet. So usually download is the big concern there, rather than upload. So usually 1 or 2 megabits per second is more than enough for a home environment. So that DSL, that copper cable, also, the further and further away you get from that office, you run into distance limitations. Some houses might be so far away on the line, and by the way, this is, if we were to draw this out, it would be a loop as well. A big copper loop with all these little houses tapped into that same cable set, right? So all these different houses. Now, if you're far enough away on that ring, you may not be able to get DSL service at all. Or it may impact the speed. Like maybe the offering is 40 megabits per second in your neighborhood, but that only happens for the first 50 people on this line. But once you get past that length, now you're down to 10 megabits per second because that's the maximum speed the cable can support at that distance, right? So that would be another way that we could run that. So we've got fiber connecting all of our offices together going right here. So each one of them taps off. Now notice I have now copper and copper serial and copper cable. So a serial connection might be again running over that copper cable, but we flip it out as a T1 circuit on that line to where we have a symmetrical 1.544 megabits per second. So we convert that copper cable over to a serial style connection. And that would plug into a router over here. Here's a cable modem connection. So this kind of copper. Now, usually, by the way, this would not be one service provider. This would be, one would be a cable provider, one would be a DSL provider. But I will say there are some that do both. For instance, I don't want to throw their name out there because they're kind of a scummy company. I've dealt with, well, at least the people that I've dealt with there. But there is a, I'll put MP as the abbreviation of this company. And what they do is they partner with the DSL provider. They partner with the cable provider. And so essentially you can sign up with the MP service provider, and they will provide you whatever services you are looking for. But behind the scenes, they're actually using this cable, which isn't there from another carrier. They're using cable modem cable from another carrier. They just kind of resell all of that kind of stuff. So it could be one of them. That's using. So we have cable. This represents a Wi-Fi signal. Again, my point here isn't to go into all the technology. Each one of these could have a full series created on it and the technology used to do it. I'm just saying that we can deliver technology over a variety of mechanisms depending on what kind of ISP we are, depending on what areas we want to reach. This might be a WISP, a wireless internet service provider, which is setting up little towers on their buildings and broadcasting wireless signal that you can tune into. And essentially, when you sign up, you get the authentication methods that you're able to jump on that. You maybe get a little dish mounted. I didn't even think of that. Dish. You can also do satellite. There are satellite providers that, not pictured here, they're in outer space. They've got the little satellites that they get their internet signal from. So all these are different ways that we can reach the end customer, but in the end, it all draws back to our central building here, and then we pipe that out to our uplink, our partner relationships, which typically come into our central location here. Now, the diagram I showed you on the previous slide represented the physical connectivity, but that gets pretty cumbersome a lot of times if you want to focus in on one specific network or zoom in into how to configure a specific device and the information that you need, and that's where we use our logical network diagrams. Now, when you get into the logical network diagram world, it's kind of like game on. Whatever you want to focus on, you can, and you can bring into perspective a particular element of the network and focus on that. For instance, up here, maybe I want to zone in. Hang on, let me get my right pen out here. I want to zoom in on the IP addresses. So in this case, I could say, okay, here's the subnet for the WAN link. Here's one IP address. Here's the other IP address on that WAN link, and those two are communicating on there. And when we get to the LAN, which is inside of the building, here's the IP address of the gateway. Here's an example PC, but it's really running the 192.168. So this is a focus on logical addressing in this network diagram. Maybe I'm looking at the inside of my service provider network. I want to see how are my different routed devices connected together. Well, we might see a diagram like this, which represents thousands of miles of territory. I mean, this could be Arizona, and this could be Japan over here on the left-hand side. So, I mean, we could just be focusing on the routed infrastructure, or maybe you have something like this, which might be used in a small business environment where you're saying, okay, this is my internal core. Here's, this line represents the switch. Here's my PCs and IP phones connected to that going through